Hello, and thank you for watching. Accurately calculating the direction and intensity of light in 3D rendered environments creates more realistic surroundings and immersive gaming experiences. Games use vector normalization to calculate the direction of lighting off a surface. This involves changing coordinate lengths of a vector to 1 without changing its direction. The formula for this involves dividing the vector by its magnitude, requiring an inverse square root. This can be taxing on a system calculating thousands of surfaces in 3D builds. The fast inverse square root algorithm provided accurate, real-time solutions while also providing more responsive and visually smooth experience in rendered environments. It calculates the inverse square root of a number with minimal memory overhead because the algorithm requires fewer operations than rudimentary techniques. The fast inverse square root algorithm efficiently calculates the inverse of the square root of some number. It is known for its use in the code for the game Quake III Arena, as it was 4 times more efficient at finding an accurate solution than other methods of the time, with less than a 1% margin of error. The algorithm implements Newton's method and bit hacking on numbers represented by the IEEE 754 format for floating point numbers. This means that raw bits are manipulated in the program instead of numeric representations of decimal numbers, providing a more accurate calculation. Before applying Newton's method, the algorithm approximates a first best guess solution using bit-level manipulation. Floating point numbers, or decimal numbers, are interpreted as bits and are adjusted directly, providing a more accurate first best guess. A magic constant is applied to the bits of a floating point number, greatly reducing the iterations needed in the next step. Newton's method takes the best guess provided by the bit hacking step and iteratively approximates the solution for the fast inverse square root. Because of the bit manipulation step, it only takes one iteration to provide a highly accurate approximation. These methods are less computationally expensive than using Newton's method alone, making the algorithm indispensable in an era of limited computing power. This table shows the accuracy of the fast inverse square root program used in Quake III Arena. True values from the dataset show that estimates from the game are well within 1% margin of error, with a maximum margin of 0.375%. Newton's method is a root-finding algorithm often taught in Calculus 1. In the fast inverse square root algorithm, it is used to refine the approximated solution provided through the bit hacking step. It is represented mathematically as x sub 1 equals x sub 0 minus a function at x sub 1 divided by the derivative of the function at x sub 0. In this iterative calculation, the derivative of the function at x sub 1 cannot equal 0 and is the slope of the function at x sub 0. X sub 0 is the best initial guess provided by the bit hacking step. X sub 1 is the next approximation, and the function at x sub 1 is the function value at x sub 1. The fast inverse square root serves as an example of how calculus affects computational methods. It showcases how mathematical concepts like derivatives and approximations are used to solve real-world problems efficiently. Due to developments in this algorithm and similar concepts, gaming and 3D development became more efficient and immersive. It paved the way for historically innovative solutions in technology and highlighted the importance of collaboration and research.